Hello and welcome. Today I will be answering Waec 2018 Physics 2 Theory question number 2. The question says state 3 materials used for making optical fibers. Now before I go on to list the materials used for making optical fibers, it is important for us to know what optical fibers are. Optical fibers are cylindrical dielectric waveguide that transmit light along its axis by the process of total internal reflection. Now I take that again. Optical fibers are cylindrical dielectric waveguide that transmit light along its axis by the process of total internal reflection. So let's go ahead and begin to outline the materials for making optical fibers. Now number one, we have glass. Glass is a material. Then number two, we have silica. Number three, we have silicon. We have silicon. Number four, we have sapphire. Number five, we have Teflon sheet. And then number six, we have polycarbonate. Now all these are the materials used for making optical fibers. They are glass, silica, silicon, sapphire, Teflon sheet, and polycarbonate. Thank you. For more videos, subscribe to our YouTube channel www.waecnecouni.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 Physics Theory question number 4A and B. Question 4A says, what is an intrinsic semiconductor? 4B, distinguish between the p-type and n-type semiconductors. Now before we define intrinsic semiconductor, what are semiconductors? Semiconductors are materials which have an electric conductivity intermediate in value between that of a pure metal and that of a good insulator. Okay, all right. So now, what are intrinsic semiconductor? Intrinsic semiconductor are conductors. They are conductors containing equal number of free electrons and holes. So they are conductors containing equal number of free electrons and holes. Now 4b says distinguish between p-type and n-type semiconductors. So for p-type, let's look at for p-type. Let's tabulate for p-type. Let's say for p-type, and then for n-type. Now here, n-type, the majority carrier here, carrier of electricity is holes, and then for n-type, the major carrier is electron. Then number 2, it carries, p-type carries a net positive charge, and then n-type carries a negative charge. So to distinguish between p-type and n-type, the major carrier in p-type are the holes, while the major carrier of electricity in n-type is electrons. P-types carries in a positive charge, n-type carries a negative charge. Now again, for the p-type, the impurity for p-type is trivalent. So here impurity is trivalent, but for n-type impurity is pentavalent. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, JAMB, waecnecouni.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 Physics Theory question number 5. The question says a missile is projected so as to attain its maximum range. Calculate the maximum height attained if the initial velocity of projection is 200 meters per second. Acceleration due to gravity is given to be 10 meters per second. Now let's write out the parameters that we are given in the question. Now, given that initial velocity is 200 meters per second, acceleration due to gravity is 10 meters per second squared, and because the missile is projected to attain its maximum range, the angle is going to be 45 degree at maximum. So the relation to find the maximum height is given to be u squared sine square theta over 2g. Now if we substitute the parameters into the relation, we have 200 squared times sine 45, now in bracket squared, over 2 times acceleration due to gravity. Now if you solve that mathematically, your answer will be 999.9 meter, which is approximately 1000 meter. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.jambwaecnecouni.com. Thank you. Hello and welcome to Tclassified. Today I will be answering Waec 2018 physics theory question number 6. Now the question says a black body radiates maximum energy when its surface temperature T and the corresponding wavelength are related by the equation maximum wavelength T equals to constant. Given the values of the constant and surface temperature as 2.9 times 10 raised to the power minus 3 mK and 57 degree respectively, calculate the frequency of the energy radiated. Now we are given a relation. The relation is we are given a relation given that wavelength maximum T is equal to constant, and then to find the wavelength maximum is equal to the constant over the surface temperature, which is equal to 2.9 times 10 raised to power minus 3 over 330. That is when you add 57 plus 273, that gives you 330 Kelvin. So this one will give us 8.8 times 10 raised to power minus 6 meter. Now we remember the formula F lambda. Remember, we want to find the frequency, and frequency is given to be V over the wavelength. Now of course V is the velocity of light. Velocity of light is given to be 3 times 10 raised to power 8 over the maximum wavelength we got earlier, which is 8.8 times 10 raised to power minus 6. The frequency will be 3.4 times 10 raised to power 13 S. So let's try to erase this so that we can see some of the things we have written clearly. Okay, All right, so we have a clear picture of what we have done. Okay, so given that the maximum wavelength T is equal to K, so we have maximum wavelength to be equals to the constant upon the temperature, the surface temperature. And if we solve for maximum wavelength, we will have 8.8 times 10 raised to the power minus 6 meter. And then since we are asked to find the frequency of the energy radiated, frequency is given as V over the wavelength. So velocity is the velocity of light and is given as 3 times 10 raised to the power 8 upon the wavelength we got earlier, 8.8 times 10 raised to the power minus 6, and that will give us 3.4 times 10 raised to the power 13 as. Thank you. For more videos, subscribe to our YouTube channel on Tclassified.com and visit our website on www.jamb.waec.necouni.com. Thank you. Hello and welcome to Tclassified. Today I will be answering Waec 2018 Physics Theory question number 7A and B. 7A says, what does the acronym laser stands for? And B says, what is a laser? Now to answer the first one, laser stands for light amplification by stimulated emission of radiation. So laser stands for light amplification by stimulated emission of radiation. Okay, now the B part of the question says, what is a laser? Now a laser is a device that generates an intense beam of coherent monochromatic light. So we write that a laser is a device that generates an intense beam of coherent monochromatic light. Thank you. For more videos, subscribe to our YouTube channel Tclassified.com. Visit our website on www.jamb.waec.necouni.com. Thank you. Hello and welcome to Tclassified. Today I will be answering Waec 2018 Physics Theory question 8. 8A says, define uniform acceleration. B. Forces act on a car in motion. List the horizontal forces and their directions. 2. Vertical forces and their directions. C. A car starts from rest and accelerates uniformly for 20 seconds to attain a speed of 25 meters per second. It maintains this speed for 30 seconds before decelerating uniformly to rest. The total time for the journey is 60 seconds. Sketch a velocity graph for the motion. 2. Use the graph to determine A. Total distance traveled by the car, and B. Deceleration of the car. So first we'll define uniform acceleration as the constant time rate of increase in velocity. So it is defined as the constant time rate of increase in velocity. Okay, so uniform acceleration has been defined. Now for a car in motion, now let's assume this is the car in motion. Now the horizontal forces are 1, the thrust, which is also known as the forward force, and then we have the frictional force, that is the backward force. Now we have the thrust, which is the forward force, and then we have the backward force, which is the frictional force. Then for the vertical forces, we have the weight, with the weight of the car, and then we have the normal reaction, and here we have the normal reaction, which is denoted as N, and then here we have the weight, which is acting downward, W. Okay, now for the C part of the question, it says a car accelerates. So let's have let's have a velocity graph with the y-axis label V and the y-axis label T. So the question says a car start from rest, that means start from zero, start from rest and accelerate uniformly for 20 seconds. So here is 20 seconds, and then maintains the speed for another 30 seconds. So 30 plus 20, we have 50, and then the car come to rest. Now the total journey is 60 seconds. So let's label here to be B, A, B, and C. So to find the total distance traveled, we calculate the area of trapezium, because that's the shape of the velocity graph, which is 1/2 into AB plus OC, and then the height, which is AD. Okay, so this is going to give us 1/2 bracket open. AB is 60. We have 60 plus 30. This will give us times 25, which will be 1125 meters. If you calculate all this together, you will get 1125 meter. Now second part of the question says to find the deceleration of the car. Now to find the deceleration of the car, we find the slope of BC, that is the slope of BC, which is deceleration is given to be BE over CE, which is equal to 25 divided by 10, which is equal to 2.5 meter per second squared. Okay, so we have succeeded in finding the deceleration. The deceleration, of course, it's negative acceleration, but we'll leave our answer as 2.5 meter per second. Thank you. For more videos, I'd like you to subscribe to our YouTube channel on Tclassified.com. Visit our website on www.jamb.waecnecouni.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 physics question number 8D. Now the question says the figure here illustrates force extension graph for a stretched spiral spring. Determine the work done on the spring. Now, as you can see from the question, the diagram is not given, but I'm going to draw the diagram and then we will determine the work done on the spring. So let's begin with the diagram. Now, okay, it's a force extension. This is force extension, and then we have this. Then we have okay, so here we have 12. Here we have 0.5. Okay, so this is 0 from the origin. Okay, so the question says to find the work done on the spring is given as 1/2 force times the extension. Now we are given the force. The force is equal to 12, and the extension from the graph is 0.5. Of course, it's given in centimeter. It's given in centimeter, so we're going to convert to meter to get the result. So work done is equal to 1/2 times 12 times 0.5 over 100 all squared. Now if you calculate all together, the result will be 0.03 joules. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, educateafrican.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 Physics Theory question number 9 A, B and C. Now question A says list two factors each that affect heat loss by radiation and 2 by convection. Now question B says state two factors that determines the quantity of heat in a body. Then question C, explain the statement the specific latent heat of vaporization of mercury is 2.72 times 10 raised to power 5 joules per kilogram. Now let us list the factors that affect heat loss by radiation. Now first, heat loss by radiation. The factors that are affecting heat loss by radiation, we have surface, area, and then 2 we have temperature is another factor affecting heat loss by radiation. Then let us look at heat lost by convection. Now we have the nature of the liquid, density, the density of the liquid. We also have the viscosity, of the liquid. Then we have the thermal conductivity, of the fluid. Okay, then we also have the specific heat capacity of fluid and exposed surface areas. So all these are the factors that affect heat loss by convection. Now let's go to the B part of the questions that says state two factors that determine the quantity of heat in a body. Now the two factors that determines the quantity of heat in the body, number 1 we have thermal capacity, thermal or heat capacity, and then we have temperature. Number 2 we have temperature. Temperature is another factor that determines the quantity of heat in a body. And let's look at the C part of the question that says explain the statement the specific latent heat of vaporization of mercury is 2.272 times 10 raised to power 5 joules per kilogram. Now it means that 2.72 times 10 raised to power 5 joules of heat energy is required or needed to change 1 kilogram of mercury at its boiling point to vapor, that is without change in temperature. Thank you. For more videos, subscribe to our YouTube channel on Tclassified.com. Visit our website on www.jamb.waecnecouni.com. Thank you. and welcome. Today I will be answering Waec 2018 Physics question number 9D. The question reads as follows. A jug of heat capacity 250 joules per kilogram contains water at 28 degrees Celsius. An electric heater of resistance 35 ohms connected to a 220 volt source is used to raise the temperature of the water until it boils at 100 degrees Celsius in 4 minutes. After another 5 minutes, 300 grams of water has evaporated. Assuming no heat is lost to the surroundings, calculate the mass of water in the jug before heating, and 2. Calculate the specific latent heat of vaporization of steam. Now let's begin with the heat supplied by heater. So number one, heat supplied by heater is equal to IVT equal to V squared over R then T. Then heat gained by water is equal to mass of water, specific calorimeter, specific capacity of water, and temperature change T2 minus T1. Now heat gained by jug is equal to C into T2 minus T1. Okay, so we have V square T over R is equal to mass of water, specific capacity of water, temperature change T2 minus T1 is equal to 220 squared times 4 times 60 divided by 35. So that will give us mass of water times the specific capacity of water is 4,200. Then we have 100 minus 28 degree plus 250 bracket open temperature change 100 minus 28, that is T2 minus T1. Mass of water is equal to 1.038 kilogram. So the mass of water in the jug before heating is 1.038 kilogram. Then the second question says to find the specific latent heat of vaporization. Now specific latent heat of vaporization is given as m v L V equals to V square T over R. So this will give us 200 squared times 5 times 60, everything divided by 35 times 0.3. So we have LV, that's latent heat of vaporization, to be equal to 1.38 times 10 raised to the power of 6 joules per kilogram. So the specific latent heat of vaporization is given as 1.38 times 10 raised to power 6 joules per kilogram. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafrica.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 physics question number 10A and 10B. 10A says define diffraction and 10B says explain critical angle. Now first, the first question says define diffraction. Now diffraction is one of the properties of waves, and it is the ability of a wave to bend around an obstacle. It can also be defined as the spreading of a wave round an obstacle as it passes through an opening. So we can write and say that diffraction is the spreading of a wave round an obstacle as it passes through an opening. Okay, now to explain critical angle, I'll produce a diagram showing okay. Now this is the incident angle, and then this is the angle of refraction directly on the interface of the dense medium. So critical angle is the angle of incidence in the denser medium when an angle of refraction in the less dense medium is 90 degrees. So here is 90 degrees. So it is the angle of incidence where the angle of refraction is equal to 90 degrees. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafrica.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 Physics question 10 BII. The diagram here illustrates a ray of light passing through a rectangular transparent plastic block. Determine the value of the critical angle, and B, calculate the refractive index of the block. Now let's have the diagram. Okay, now here is 44 degrees. So critical angle is equal to 90 minus 44, which is equal to 46. Okay, now let's erase some of the mistakes. Let's erase it quickly and then we'll continue. Let's erase this. Okay, so we have the critical angle given to be 46, and that answers the first question, which is to determine the value of the critical angle. So to find the refractive index, which is denoted as n, is equal to 1 over the sine of the critical angle, which is equal to 1 over sine 46 degree. This will give us 1.39. so the refractive index of the block is 1.39. Thank you. For more videos, I'd like you to subscribe to our channel www.educateafrican.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 Physics question number 10C. It says a pipe closed at one end has fundamental frequency of 200 Hz. The frequency of the first overtone of the closed pipe is equal to the frequency of the first overtone of an open pipe. Calculate the fundamental frequency of the open pipe, calculate the length of the closed pipe, and then calculate the length of the open pipe, given that the speed of sound in air is equal to 330 meters per second. Now let's begin with the closed pipe. Now first overtone is equal to 3 F0, which is equal to 3 times 200, which is equal to 600. And so for the open pipe, all harmonics are possible. So first overtone is equal to 2 fundamental frequency, which is equal to 2 times 2 times F naught, which is equal to 600. So making F naught the subject of the formula, we have 600 divided by 2 is equal to 300 Hz. Now for the closed pipe, F, that's the fundamental frequency, is equal to V over 4L, which is equal to L is equal to V over 4 fundamental frequency, which is equal to 330 divided by 4 times F naught is 200, and this will give us 0.412 meter. Okay, now again for the open pipe, force frequency equals to V over L, and that will give us 600 equal to 330 over L. So L is equal to 330 divided by 600. That will be equal to 0.55 meter. So with this, we have been able to calculate the fundamental frequency of the open pipe, which is this 300 Hz, and then the length of the closed pipe, which is this is 0.412 meter, and finally the length of the open pipe is 0.55 meters. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 physics question number 11A. It says define reactance, and 2, define impedance in an AC circuit. Now first, reactance is the opposition to the flow of alternating current offered by a capacitor or an inductor or both. So we have that reactance is the Hello and welcome. Today I will be answering Waec 2018 physics question number 11A. It reads, define reactance in an AC, and number 2, define impedance in an AC circuit. First, reactance is the opposition to the flow of alternating current offered by a capacitor or an inductor or both. And then we can define impedance as the overall opposition of a mixed circuit containing a resistor, an inductor or a capacitor. So just like I said, Reactance is an opposition to the flow of alternating current. Okay, it is offered by a capacitor or an inductor or both. Then impedance, like I have defined it, impedance is the overall opposition of a mixed circuit containing a resistor, an inductor and a capacitor as RLC circuit. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2018 Physics question 12D. Now the diagram here illustrates an AC generator. When the coil is rotated, an EMF is induced in the coil. Now explain why an EMF is induced. 2. State the purpose of the slip rings. Then 3. Name and state the law used to determine the induced current. And then number 4, state 2 ways to increase the induced EMF. Now for the purpose of answering this question, now I'm going to explain to us very quickly the EMF of an AC generator. Now the EMF is induced because the coil rotates at a steady speed about a fixed axis in the magnetic field of the electromagnet. It cuts through the magnetic lines of force. So the EMF is induced because the coils rotate at a steady speed about the fixed axis in the magnetic field of the electromagnet. It cuts through the magnetic line of force. Now secondly, the direction of the current is reversed in each half of the rotation of the coil. So the purpose of the slip ring is because the direction of current, that is the direction of current is reversed in each half of the rotation of the coil. Okay, Then number 3 says name and state the law used to determine the induced current. Now the law used to determine the direction of the induced current is the Lenz's law. So we have the Lenz law is the law used to determine the induced current. And then it states that Lenz's law states that the direction of the induced current, that is the direction of the induced current is such as oppose the change producing it. All right, so that is Lenz's law. Now lastly, the question says state 2 ways to increase the induced EMF. Number one, the induced EMF can be increased by any of the two of the following: increase speed of rotation by increase speed of rotation, and secondly by increasing the number of turns, increasing the number of turns. And then you can also increase, number 3, you can also increase the area of coil. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be solving Waec 2018 physics question number 12A and B. Question A says define binding energy in an atom, and question B says list 3 evidences to support the claim that X-rays are electromagnetic waves. Alright, now binding energy is the minimum energy required to separate the nucleus of an atom. It is binding energy is the minimum energy required to separate the nucleus of an atom. All right, now I want to list the 3 evidences to support the claim that X-rays are electromagnetic waves. There are actually many, but I will mention few. Now 3 evidences in support in the claim that X-rays are electromagnetic waves are: number 1 is that X-ray they can be polarized. Number 2, they can travel through a vacuum and then number 3, they are not they are not affected by magnetic field. All right, thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafrican.com. Thank you. Hello and welcome. Today I will be solving problem in Waec 2018 physics question number 12C. The question says list 3 peaceful uses of nuclear energy. Of course, we know nuclear energies are energies that are released from nuclear reactions. Okay, so let's begin to list the peaceful uses of nuclear energy. Now, number one, we have it is used in the treatment of tumor. It is used in the treatment of tumor. Number 2, nuclear energy is used to power submarines. It is used to power submarines. Now, number 3, nuclear energy is also used to generate electricity. It is used to generate electricity. So these are the peaceful uses of nuclear energy. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you. Hello and welcome. Today I will be solving problem in Waec 2018 physics question number 12D. Light of wavelength 4.5 times 10 raised to power minus 7 meter is incident on a metal, resulting in the emission of photoelectrons. If the work function of the metal is 3 times 10 raised to power minus 9 joules, calculate the frequency of the incident light. 2. Energy of the incident light. 3. Energy of the photoelectrons. Given the speed of light is 3 times 10 raised to power 8 meter per second, and the Planck constant 6.6 times 10 raised to power minus 34 joules. Alright, so first we'll find the frequency. Frequency 1, we find the frequency, which is the speed of light over the lambda, which is equal to 3 times 10 raised to power 8 upon the wavelength, which is 4.5 times 10 raised to power minus 7. Now this will give us 6.67 times 10 raised to power 14. This is 14 hertz. Frequency is measured in S. So secondly, to find the energy of the incident light, energy is equal to the Planck constant times the frequency, which is equal to 6.6 times 10 raised to power minus 34 times the frequency that we got, which is 6.67 times 10 raised to power 14. Now total we have 4.4 times 10 raised to power minus 19 joules. Then thirdly, to find the energy of the photoelectrons, kinetic energy is equal to energy minus the work function, which is equal to 4.4 times 10 raised to power minus 19 minus 3.0 times 10 raised to power minus 9, and this will give us 1.4 times 10 raised to power minus 19, and this is measured in joules. Thank you. For more videos, I'd like you to subscribe to our YouTube channel, www.educateafricans.com. Thank you.